So, as we start college trigonometry, I just want to make sure that everybody is aware. I have kind of mapped everything out, and I believe we are going to be able to spend 2 days on each section. We do need to cover all of Chapter 6 and all of Chapter 7 for those of you that possibly have a book. I will be getting you either copies of the problems from the pages of those books, or I will be providing worksheets. Also on my Google Classroom, if you've been on there, you will notice that there is a blank copy of all the note sheets. So if you are able to print them out, you can follow along with that. Otherwise, I will be pausing the video. You're not going to be sitting and watching me write. I'm going to be talking about something. I'm going to pause the video and fill in information. I would recommend that you also pause the video when you need to copy things down that you need to. So hopefully I'll be able to get each day's notes or each section's notes done in one video. I'm limited to 15 minutes. So my goal is to get all of the notes in one day, and then the second day there won't necessarily be a video. We will still meet online, and you can ask any questions. So let's get going. The first section is just all about angles, and so a lot of this you should remember hopefully from geometry. And actually I would challenge you to turn off the video now and fill in as many of these definitions as you think you know, and then come back and see if you're right and fill in the ones that you don't know. So to begin with, we have the definition of an angle from a geometric perspective, and then also from our new trigonometric perspective. What might the difference of those be? So geometrically, it's a set of all points determined by two rays having the same endpoint. So if I have one ray, OA, and I have a second ray coming from that second end, or that same endpoint, this is OB, then I'm going to have angle AOB or BOA. So in trigonometry, it's slightly different. It's the rotation of rays. So if we start with a fixed ray, L1, and then we rotate that, so if we have this and we're just going to rotate this angle up, so we're going to rotate that to the position of L2. And so also notice that two angles, we're going to jump right into coterminal angles. If I have this angle, I have a coterminal angle, which means if I go all the way around the circle and then up to that point, that's going to be a coterminal angle. So there's my definition of coterminal angles, angles with the same initial and terminal rays. So as you saw, I started with the same initial ray, and I came around to the same terminal ray. Standard position simply means we're using the rectangular coordinate system, and our vertex is at the origin. Though I didn't draw a coordinate system on these, this would be kind of like where the origin would be. And then the positive x-axis would be the initial side. If we rotate counterclockwise, if you notice on both of these angles for this showing the trigonometric definition, I moved in the counterclockwise direction. In other words, the opposite way that a clock would go gives us a positive angle. And if we rotate in the clockwise direction, we're going to get a negative angle. And a quadrantal angle is simply an angle that the terminal side is on the x or the y-axis. So in other words, an angle that has a measure of 0, 90, 180, 270, 360. Keep adding 90 degrees, and those are all going to be quadrantal angles. Okay, so also, angles are denoted with Greek letters, the lowercase Greek letters. So this is alpha, beta, gamma, theta, and phi. We typically, mostly, I will, and oftentimes you'll see in books, the ones that are most often used are going to be alpha, beta, and theta. So alpha, beta, and theta. Okay, this next part also, as far as the degrees go, you should be able to fill in this column for all those definitions for in terms of degrees. So I'd like you to, again, to pause the video and fill in those definitions for degrees, and then we'll come back and talk about radians. So hopefully you remember these, that a complete circle is 360 degrees, a right angle is 90 degrees, an acute angle, small cute angle, is between 0 and 90 degrees, an obtuse angle is between 90 and 180 degrees, Remember again, complementary angles from geometry are two angles. We're using alpha and beta. If you noticed here, I used an acute angle. I said it's between, theta is between 0 and 90, and for an obtuse angle, theta is between 90 and 180. Complementary angles, alpha plus beta, have to add up to 90 degrees, and supplementary is alpha plus beta equals 180 degrees. We're going to jump ahead real quick because I want to show you an animation of what a radian is and define a radian, and then we're going to come back and we're going to define what all of these are in terms of radians. So this is the definition of 1 radian. It's the measure of the central angle of a circle formed by the arc in equal length to the radius. But what exactly does that mean? So there's my radius that is forming my circle. Now if I take that same length of that radius and I create an arc of equal length, that is 1 radian. So if we duplicate that, we're going to get 2 radians, 3 radians, and then remember that pi is just 3.14, so a little bit more than 3 is going to give us pi radians, which is halfway around the circle. And if we duplicate that, that's where we're getting our 2 radians. 2 pi radians, I'm sorry, for a complete circle. So from the video, we saw that 180 degrees is pi radians. If we divide 180 by 2, we get 90 degrees. So we would also divide pi by 2, so we can see that 90 degrees is pi over 2 radians. If we divide 180 by 3, we get 60 degrees. Divide pi by 3, we get pi over 3 radians. If we want to know what 1 degree is, so if I divide 180 by 180, I get 1 degree, then that would mean that 1 degree is equal to pi over 180 radians. If I divided this one by 180, I divide this one by 180. Similarly, if I were to divide pi radians by pi, I get 1 radian. So that would equal to, if I divide by pi, I need to divide this side by pi. So 180 divided by pi degrees would be 1 radian. So coming back to the first page of these notes again and filling in these corresponding radians for what the acute angle, obtuse angle, etc. are in terms of radians, you can go ahead and fill those in. And then another thing that we're going to be using again in a couple minutes for some of the problems that we're going to be doing, a degree is made up of 60 minutes, and a minute is made up of, just like in time, 60 seconds. So the length of a circular arc. If an arc of length s on a circle of radius r creates an angle of measure theta, wow, that's a lot. So if we think about this, if I have an arc length of r up here, circle of radius, then my angle measure is going to be 1 radian. If I think about this equation down here, if my angle measure is 1 radian, then my arc length is going to be 1 times whatever my radius is. If my arc length is half of a radian, then my arc length s is going to be half of whatever my radius is. Keep in mind when you're using this formula or this rule, theta always has to be or always is in terms of radians. Again, a lot of confusing words here again in the area of a circular sector. Again, theta is in radian measure of the central angle of a circle with radius r. Then the area of that sector is 1/2 r squared theta. Now, if you notice, this is very similar to the area of a triangle, which is 1/2 pi r squared. So maybe that will help you remember when you're using this of the similarity to a formula that you're already familiar with. So the last 2 topics are about our speed, and then we're going to go through 6 problems. So first of all, angular speed is the angle that's generated in a unit of time by a line segment. So how big of an angle is going to be generated in 1 unit of time? So again, think of a speed as the distance, so in this case it's our angle, divided by time. Linear speed is what we're more commonly used to. When we go somewhere, we are going in a line to someplace. So it's the distance that p travels in a unit of time. So again, we're thinking about our typical distance equals rate times time. If we flip that around, we get rate equals distance over time. So how do we convert from linear speed to angular speed? So remember, our linear speed is the length of our arc. So up above we used s for the length of our arc up above, divided by time. But then remember that our s, again divided above the length of a circular arc, is r times theta over time. So basically this is telling us that our linear speed equals r times our angular speed, because remember this theta divided by time is our angular speed, so it's r times our angular speed. So now let's get on our third page and do a bunch of problems. So two positive and two negative coterminal angles. Basically, two positive coterminal angles, I just need to go around the circle once and then go around the circle again. For two negative coterminal angles, I need to go around the circle backwards. So let's go ahead and find two positive and two negative coterminal angles. So there we have two positive coterminal angles and two negative coterminal angles. To find the angle that's complementary to 56 degrees, 41 minutes, 32 seconds, remember complementary, they need to sum to 90 degrees. So we basically need to subtract this from 90 degrees. So I have 90 degrees and 0 minutes and 0 seconds. Well, that's equal to, if I just borrow one of those degrees, now that's 60 minutes and 0 seconds. And I just need to borrow a minute, so 59 minutes and 60 seconds. And then I can just subtract my 56 degrees, 41 minutes, and 32 seconds using column addition, column subtraction. And I get 33 degrees, 18 minutes, and 28 seconds. So writing 150 degrees in radian measure, so we basically just need to set up a proportion. And if you remember, 180 degrees is equal to pi radians. So we need to find out 150 degrees is to 180 degrees as what is to pi radians. So we're going to go ahead and set that one up. And then the same with this one, 3 radians in degrees. So again, we know that 180 degrees is pi radians. So 3 radians is how many degrees? And then after we find the degrees, then we can break that down, that decimal part down into the minutes and seconds. So go ahead and stop the video and solve those two problems. So that first one, when we simplify after we do our cross multiplying and divide by the 180, we get that x is 5 pi over 6. And whenever you're changing it into radian measure, please make sure you're keeping it in terms of pi, because that's going to be an exact answer. The second one now, we're going to get x equals 171.8873 degrees. So we know that we've got 171 full degrees. And now there's 60 minutes in 1 degree. So we're going to multiply what portion of this is going to give us our minutes. So 0.8873 of a degree gives us 53 minutes, 0.2403. So now I've got 53 minutes. And then I'm going to take that 0.2403, and there's 60 seconds in a minute. So when I multiply that, I get 14.4187. So there are 14.4 seconds. So number 5, a central angle is subtended. That simply means that it's created by an arc 10 centimeters long on a circle of a radius 4 centimeters. So I've drawn a picture of what we have. It's asking us to approximate the measure of theta and then the area of that circular sector. So we're using those two formulas. So please pause the video and do those two problems. So keep in mind for this problem, basically we're using those two formulas and we're plugging in the information we know to get the information that we need. The big thing to keep in mind for both of these problems is that theta is in terms of radians. Number 6 is asking us to find angular speed and linear speed. So again, we're going to be setting up and solving some ratios. So setting up my problem here, angular speed is theta over t, 800 revolutions per minute. Setting up a unit conversion, 2 pi radians are in 1 revolution. So I get 1600 pi radians per minute. Then for the second one, linear speed is r times my angular speed, so 12 times the answer I got above. Then I'm doing unit conversions to get 57.12 miles per hour. I know I went through this last example quickly. Please make sure you come to our live discussion and come prepared to ask any questions you may have.